Good morning. I am Dr. K. Kannan, working as a professor in the Department of Mechatronics Engineering, Kamaraj College of Engineering Technology, Virudhunagar. I welcome you all to this video lecture on the topic Application of Machine Vision Systems in Robotics. Machine vision. Machine vision is a technology that enables a machine to interpret and process visual information similar to the human vision. It is widely used in industrial automation, quality control, robotics and artificial intelligence. As per the definition, the term machine vision is defined as the ability of the machine to acquire, process and analyze the visual data to make some decisions regarding the object of interest. There are so many differences between the computer vision and machine vision in terms of different aspects. We will discuss one by one. First of all, computer vision is nothing but a technology that helps computers to see and understanding images as well as videos, whereas the term machine vision is defined as a specialized type of computer vision used in industries for automation. From the definition of these two terms, computer vision and machine vision, we can infer that machine vision is a subset of computer vision and machine vision is applicable for applications in the industry side. The main purpose of computer vision is to analyze, interpret visual data for tasks like facial recognition, self-driving cars, etc. That means the application of computer vision is widespread, whereas the application of machine vision is limited to industries for the purpose of inspecting products, guiding the robot and ensuring quality products in the manufacturing line in any automated industries. And computer vision is used in smartphones, security cameras, healthcare as well as in self-driving cars, whereas machine vision is used in manufacturing industries, robotics, assembly lines and industrial automation. The process of computer vision is mainly based on the cloud. It is AI powered and works on various platforms, whereas machine vision works in real time on factory floors using industrial cameras as well as sensors. To acquire the image of object of interest, the machine vision uses a well defined camera as well as the imaging sensors which is suitable or satisfy the industrial standards. The flexibility of the computer vision, in the sense it is used in many fields as well as in applications, whereas machine vision is designed for a specific industrial task like a defect detection and barcode reading. So in this slide we briefly described the differences between the term computer vision as well as machine vision system. The functions of machine vision system is categorized into three classes. The first one is sensing and digitizing image data. The second one is image processing and analysis. The third one is application. To perform all these functions, it is having a separate set of hardware as well as separate set of softwares. Here the camera, which consists of the optics as well as the imaging sensor, is used to capture the image of object of interest. Suppose if you want to get the clear image of the object of interest, then proper lighting should be provided. Always the output from the camera, whether the camera may be a C-series sensor, a CMOS sensor, a CAD sensor, normally the output from these imaging sensor will be analog in nature. Suppose if you want to process the image occurred by these type of imaging sensor using a computer, then there is a need to use a ABD converter, analog to digital converter, to convert the analog output from the camera into the digital one. For that we are using the ABD converter. And also if you want to process the image captured by these cameras using a computer, then there should be some interface between the computer as well as the camera. For that only we are providing the frame grabber, and inside the computer we will feed the software for processing the algorithms. So to store the algorithms it will use a memory, and to give the input to the computer it will use a keyboard, and to get the output we will use a display. And suppose if you want to perform certain tasks using the robotics, based on the extracted information from the image captured by the camera, then there should be interface between the computer and the robot controller. So there is some interface between the computer and robot controller, and using the robot controller the robot performs the defined task. So these are the 3 steps involved in the machine vision for any type of applications. Here we are separating the hardware as well as techniques used for the different functions of machine vision system. As discussed in the earlier slide, the first function is sensing and digitizing image data. For sensing and digitizing image data, it uses the camera with the proper lighting as well as frame grabber. The function of the frame grabber is to interface the computer with the camera, and the ABD converter converts the analog output from the camera into the digital one, so that the captured image will be stored in the computer. To capture the clear image of object of interest, then there should be a proper lighting. So these are the hardwares which are used in the first function of the machine vision system, that is sensing and digitizing image data. The techniques involved in this first steps are signal conversion. It uses sampling technique, quantization technique and encoding technique, and these 3 techniques are used to convert the analog image captured by the camera into the digital one. After that, to store the image captured by the camera inside the computer, there is a need for the frame grabber, and there should be some proper lighting to capture the clear image of the object of interest. And the second function of this machine vision system is image processing and analysis. The hardware involved in these steps are the computer, monitor equipped with a monitor and keyboard, auxiliary storage, as well as we are using certain programming software to process the algorithms. And the third function is application. The application may be inspecting a part or identification of a part, or it may be used for visual surveying as well as navigation of robots inside the industry without any human intervention. For that, it uses a separate hardware which is called as robo controller. So the first step, sensing and digitizing image data, the function is to convert the visual information of object of interest into a electrical signal. For that, we are using the imaging sensors or visual sensors. The output from the visual sensors are analog in nature. To convert the analog output from the sensor into the digital one, we are using sampling technique, quantization technique, so that the output from the camera will be the digital one. Sometimes the ABD converter will be integrated with the analog camera, so that the output from the camera will be the digital one. And the techniques involved in the first step is sensing and digitizing image data are imaging techniques, effects of sampling and effects of quantization. And the second step is image processing and analysis. Here, if we capture the image of object of interest using a CMOS camera or CCD camera, the size of the image will be more. So if you want to reduce the size of the image before storing it into the computer, then there should be some processing algorithm so that the image size will be reduced. For that, we can use the digital conversion technique or windowing technique. The second one, to segregate the object of interest from the other objects in the background or foreground, we will use these 3 techniques in the segmentation process. They are called as thresholding technique, region growing and edge direction. Sometimes we will capture the color image of the object of interest, but it is enough to have only the grayscale image. At the time, we can go for the thresholding technique, which will be used to convert the color image into grayscale image and a grayscale image into the binary image. After that, we will extract the features of the object of interest. For that, we will use the feature extraction technique followed by the object recognition technique. And application, there are 3 levels of difficulty associated with the machine vision system in any type of application in the manufacturing industry. Sometimes the object can be controlled using both position and its appearance. Sometimes either position or appearance of the object can be controlled, but not both. Sometimes both position as well as appearance may not be useful for controlling the object. But the robotic application of machine vision system fall into the 3 broad categories which are listed below here. Inspection technique, we can identify the exact features of the object of interest, or we can identify whether the particular object is present inside the scenario or not, or it may be used for visual surveying and navigation of robot inside the industry. With this, we will close today's session. Thank you.